Potentially 250 U.S. workers will die this year from falls alone. Thousands more will become injured from falls, and some of them not returning to work ever again. Every one of these falls is preventable. Plan, provide, and train. Plan the job safely. Provide the proper equipment for the workers, and train these people on how to use that equipment properly. Yes, welcome to the Safety View, brought to you by the Environmental Health and Safety Training Institute, where we look at today's safety practices and training. Once again, the Occupational Safety and Health Administration, OSHA, has launched the annual National Fall Prevention Stand-Down for the period of May 4th through 15th. The purpose of the Fall Prevention Stand-Down is to raise awareness of preventing fall hazards in construction. Fatalities caused by falls from elevation continue to be a leading cause of death for construction workers. This year, OSHA's goal is for more than 20,000 stand-downs involving more than 3 million workers to take place. If this goal is met, it will have touched 4 in 10 construction workers in the country. With only a couple of exceptions, OSHA requires fall protection at just 6 feet. So, what is fall protection? Well, fall protection is a group term that includes fall prevention, fall restraint, and fall arrest. Now, fall prevention prevents people from reaching the fall hazard by creating a physical barrier between the person and the fall hazard, such as a guardrail system. Now, fall restraints prevent people from reaching a fall hazard through a tie-off system, such as a full body harness and a predetermined length of rope, cable, or retractable lifeline. And fall arrest stops a fall that is in progress through a tie-off system, such as a full body harness and a shock-absorbing lanyard. We are going to break with a message from our sponsor. When we get back, we have Mr. Lee Stottlemyre. We'll be back. Welcome back to the Safety View. We have Lee Stottlemyre, a veteran safety training professional with Ram Tool Construction Supply Company. It's good to see you again, Lee.
Thanks, Martin. Thanks for having me today.
So, Lee, how long have you been providing the safety training?
Gordon, it's been about 14 years in the construction and utility markets.
And your training specifically is in fall protection and prevention, is that correct?
That's correct. Fall protection is constantly changing, so we have to constantly train our people.
Right, great. We have some training footage of Lee performing a fall protection and prevention segment right here for you.
Hi, good morning, everybody. My name is Lee Stottlemyre. I'm the safety specialist for Ram Tool and Supply. Today we're going to talk about some fall protection. Now, before you go ahead and you pull your fall protection out of your your trailer, you need to evaluate the job site. You need to remove the fall hazard from the area before you go to PPE. Now, that being said and done, the first thing that you need to do when you decide that you're going to use fall protection is you need to find an anchor point. Now, that anchor point by the OSHA requirements, it must be rated for 5,000 pounds of dead weight. 5,000 pounds, that's the weight of that truck. If it cannot handle the weight of that truck, you have no purpose whatsoever tying off to that anchor point. The next thing that you have to figure out when you find that anchor point is you need to make sure that you've got enough clearance between that anchor point and the ground. All right, how high do you need to be in order for a standard lanyard to save your life? That is 19 feet. 19 feet for a standard lanyard. Now you're going to hear different numbers from different manufacturers, okay? But the ANSI standard is going to be 19 feet, and this is how we calculate that. We're going to take this 6-foot lanyard. We're going to attach it to a 6-foot person. Now, when that person falls, they're going to fall the length of the body, the length of the lanyard. Now this lanyard's going to pull out. The pull out on the lanyard is approximately 4 foot. And the last thing is a 3-foot safety factor. 6-foot man, 6-foot lanyard, 4-foot pull out, and a 3-foot safety factor. 19 feet. That makes pretty good sense, right? All right. Now, you look at your work environment, you look at your area, and you say, hey, I've got a good 5,000 pound anchor point here, but I don't have 19 foot of fall clearance. How am I supposed to protect myself on that job site? Well, that's when you're going to go ahead and use something like a retractable lifeline. You can use something like this. Like this. They're all going to be the same. Now, when you use this, you're going to connect this to that same anchor point. You're going to connect it up there. And now, when you figure your fall clearance, when you're going to use a retractable lifeline, you're going to do this. It's going to be shoulder height and above. The class of retractable is going to determine how far you're going to fall before full arrest. This is a Class B retractable. It will come to full arrest within 52 inches. So your fall calculation will be this. 52-inch fall clearance plus your safety factor is how high you need to be above the deck for this to save your life. See how quick that is to lock up? Great. Now, I like retractables. Retractables are a really good piece of equipment. And here's why they're a really good piece of equipment. They do not let you fall that far. So the forces to your body are not going to be so great. Here's the other great thing about a retractable, is that you may fall only a short distance, and rescue is a big consideration that we have to worry about on the job site. If your people need to be able to reach over the edge, grab you and pull you back up, there is that possibility. When we talk about an anchor point and fall protection, I told you earlier that that anchor point had to be 5,000 pounds. Now 5,000 pounds must hold dead weight, as I said earlier. Now when I say anchor point to you, you're thinking more likely you're thinking about structural steel, concrete columns, concrete slabs. I'm thinking as a fall protection professional, I'm thinking about how do you connect to those items. Now one of the most common items that you're going to see out in the field to connect to that structurally strong item is you're going to see a cross arm strap, tie-off adapter. It doesn't matter, they all got different names. This is probably the most common anchor point used in the field today. All right. Now this anchor point is also the most installed incorrectly item in the field today. All right, so now let's go ahead about how do you connect this thing up. So you're going to take this cross arm strap, tie-off adapter, and you're going to put it across that structurally strong member. You're going to take it and you're going to feed the small loop through the big loop. And you're going to cinch it down. Now, is that a correct installation for this piece of equipment? The answer is no. This is a partial installation. Your anchor point should always be shoulder height and above, because all of your fall protection equipment is designed around a 6-foot free fall. What do you need to do at that point? You need to complete the installation. Go ahead and complete it. Wrap it. Take the extra slack. You're going to wrap it around that structurally strong member. You're going to wrap it. You're going to wrap it. And at the very end, you're going to take that small D-ring and you're going to lock this off. You're going to cinch it down. Now you brought your anchor point up to an appropriate level. It's also closer to the structural member, so it's stronger. Now, the other way this is installed incorrectly is people, let me go ahead and remove this. People are going to take this anchor point. They're going to connect it in a basket around their structural member. They're going to connect it like that. Now, this, for lifting dead material, will work just fine. However, in fall protection, you cannot install an anchor point like this. The connection device, the snap hook, the carabiner that's going to go in here is not rated for 2 items within that connection device, so you cannot do that with fall protection. Now, another more common anchor that's out there around the steel erection business is the beamer. Okay. Now, these beamers are designed to go on a steel I-beam on the flange. Now, this is designed to go above you. Now, when you put this in above you, it's great. You can work all day and you can take a fall on it and it's going to hold. You're going to see some people do something incorrectly with this item and they're going to put it at their feet. Now, when you put in a beamer at your feet, you cannot use a standard lanyard or retractable with it. You must use one that is rated for a 12-foot free fall. Okay? The last anchor that I'm going to talk about in this short segment here is I'm going to use this temporary concrete anchor. Temporary concrete anchors are absolutely fantastic. You got to look at your concrete, make sure it's rated for 3,000 psi, and you got to have a good clean hole on it. Look at the manufacturer's instructions. Drill your hole, pull this and insert it. Now, what people do incorrectly most of the time with this anchor here is they do not clean out the hole. That is a requirement. You blow out that hole so that you've got a good solid surface, a gripping surface, for this to hold you in the event of a fall. Great. Now, we've talked a little bit about the anchor point, and we can go all day about the anchor points. But hey, we don't have enough time for that. Let's go into the body wear, the harness. Now, if you've got to wear a fall protection harness, you have to do one thing. You have to inspect it every day before you use it. Now, when you take this harness and you go ahead and inspect it before you use it, you're going to hold it up. You're going to look on the back and you're going to make sure that the fall load indicators have not been activated in a fall or forces to the body. You're going to check and make sure that you've got a serial number tag. That serial number tag is underneath the cover on this particular harness. Now, when you inspect it, you're going to take it by the rear D-ring. You're going to inspect that rear D-ring for any kind of rust or deformity, and it must operate as designed. It must be able to go up and down. Check underneath it, make sure that there's no rips or tears. All right? Now, if you're satisfied with that, take that thing by the D-ring, take that harness, and you're going to trace the webbing. You're looking for rips, tears, burns, chemicals. Rips, tears, burns, chemicals, all the way down. Check it. Turn it around, do the front part. Your load-bearing surfaces, okay? You're looking for rips, tears, burns, chemicals. Come all the way down. When you come to a metal component on the harness, you look at that metal component, and you're looking for rust or deformity. And if it has a moving part, you need to make sure it moves as designed. All right, rips, tears, burns, chemicals, rust or deformity, operates as designed. All right, great. Flip it over and check the bottom part of the harness. Now we're going to look at the leg straps, and we're going to check those leg straps the same way. We're looking for rips, tears, burns, chemicals. Rust or deformity, operates as designed, all the way down. Rips, tears, burns, chemicals. Checking that harness all the way down. Once you're satisfied with that harness for that day, now you can go ahead and use it. You've got this harness, and you're going to go ahead and put it on. Now, when you put this harness on, you need to make sure that you're wearing it correctly in order for it to work as designed. The first thing that you need to do is you need to put it on so that the D-ring, the center D-ring on the back, is high between your shoulder blades. The purpose of that D-ring being high between your shoulder blades is so that when you take a fall, you're going to take the force is going to be transferred down to the full axis of your body. Also, on that D-ring, only one item can be connected to it at any given time. All right, that's the rear D-ring. Chest strap. The chest strap needs to be across the center of your chest, right across the middle. The reason for the chest strap is so that in the event of a fall, you do not come out of your harness. That's how tight it needs to be. It just needs to be connected. You want to avoid putting your D-ring too high, because if your D-ring is too high up here, when you take a fall, it's going to go up into your throat, it's going to knock your head off, and then it's going to choke you out and you'll die that way. All right, bring it down around the center. Now, if the chest strap is too low and it happens to be down around here, what ends up happening in a fall is that you end up going head first and you run the possibility of coming out of that harness. Make sure it's on correctly. Put it across the center here. Last thing on the harness we're going to talk about is we're going to talk about the leg straps. Leg straps need to be connected. They need to be connected at all times. All right, now when you put these things on, you need to make sure that they're not too tight. And the way we do that is we use the 2-finger method. We're going to put the 2 fingers between the webbing and your body. Webbing in your body, that's it. Now some people get confused. Do I do it this way or this way? It doesn't matter, okay? Just put them in there, that's about it. Is that comfortable? Nope. Is it uncomfortable? Nope. But it's going to allow you to go home. Now let's talk about if your D-rings, if your leg straps happen to be too tight. If your leg straps happen to be too tight, what you're going to do is you're going to cut off the circulation on the backs of your legs. That artery back there on the backs of your legs controls about 70% of the blood flow to your internal organs. You don't want to cut that off. All right. If you get lightheaded, you're going to fall out and you're going to have a fall. All right. So check your leg straps. Make sure they're not too tight. Now, if your leg straps happen to be too loose, if they happen to be down around here, pretty dangerous. In the event of a fall, if your leg straps are down here, they're going to scream north, and that's what's going to happen, okay? All right, let's move forward. The last thing I want to cover in this discussion today is that when you go to a work area and you have to use fall protection, you need to also think about the rescue plan. That should be something that everybody thinks about, everything from management to the actual employee. What does that mean? The OSHA requirements for rescue are prompt, so you need to get that person down as soon as you can.
That was some impressive training. Thank you very much for being here with us today. Ladies and gentlemen, Mr. Lee Stottlemyre of the Ram Tool Construction Supply Company. Of the Safety Training Exchange, and we went into the field with him. With the cooperation of Mast Climbers LLC, Greg showed us what properly erected scaffolding looks like. Now remember, this segment is only awareness training. It is not to be mistaken for scaffold competent person, erector, or user training. Greg, the Safety Training Exchange. Tell us a little bit about that.
Gordon, the Safety Training Exchange is something I invented to help users and providers of safety training find each other instantly online.
That sounds very simple and convenient. So safetytrainingexchange.com. Go visit Greg there, and we're going to now go to this clip.
Hi everyone, we're in Lithonia, Georgia at Mast Climbers LLC. I'm meeting with the owner, my good friend Bobby Reese. How you doing, Bobby?
Hey Greg, how you doing today?
Great, good to see you. Bobby's going to tell us a little bit about scaffolding today.
Go ahead, Bob.
Okay, I would just want to start and talk about the safe use of scaffold with you a little bit today. And as with any building or any type of structure, a scaffold starts with a good base or a good foundation. And with scaffold, it begins with mud sills. You must have a firm foundation that we put our screw feet on, and we build our vertical members of our scaffold off of. Once we have that foundation established and we know that our scaffold is on that foundation, what we do is we then put in horizontal or diagonal members to support our verticals and tie our verticals together so that they are firmly in place so that we can then start with our planking and our access and our guardrails. So as you can see with this scaffold, all of the members have been placed on mud sills. Then what we want to do is we want to square and we need to plumb up our scaffold. So all the vertical members have to be aligned perfectly vertical or plumbed up, and then we square them off with our horizontal members of our scaffold. As we were saying, we have the members actually hold our verticals together, and as you can see, each of the members have to be pinned together properly to support these vertical members. As you can see, we've pinned our horizontals in, we've pinned our screw feet onto our verticals so that we can plumb the scaffold and square it up properly. So once we've done that and we've started putting our horizontals in, once we establish that we've got a structure that's plumb and square, we then plank it out. As you can see here, we've used aluminum plank, and we've planked our area fully, completely, with no gaps in between the planking. The planking's rated, so we know what the capacity of the planking is. In this case, an aluminum plank is good for 75 pounds a square foot. So once we've done that, we know what our capacity of our scaffold is, and as you can see, this scaffold's been tagged with a maximum capacity of 1,250 pounds, or five personnel up on the scaffold at the same time. So we know what the scaffold will support, because we certainly don't want to overload the scaffold and have a collapse. Once we've done that, now we have to get up and down the scaffold. Well, how do we do that? There's a couple of ways. As you can see in this scaffold, we have an integrated stairway that comes, a walkway that walks up and down the scaffold, an inside stair. Other scaffolds have the option of putting a ladder up the outside of the scaffold. Both ways are acceptable. Probably the safest way is to have an internal stair. So here we are on our scaffold, and we were talking about how do we protect our workers from falling to a level below. OSHA says that we must protect workers from falling to a level below us when we reach a height of 10 feet. Some people actually reduce that to 6 feet. You'll find some general contractors, and as OSHA is a minimal standard, they are perfectly within their safety programs to reduce that fall distance to 6 feet. The way we guarded in this scaffold against falling to a level below, we added a top rail and a mid rail to protect the worker from falling to a level below. So we have to have a top rail, which is defined as a distance of 42 inches plus or minus 3 inches above the floor we're standing on. So we have a mid rail that's 42 inches, or we have a top rail that's 42 inches, then we have a mid rail that is in between the surface we're standing on and the top guardrail, which holds us into position and keeps us from falling. We also equip the lower level, or around the floor we're standing on, our floor surface, with the toe board. The toe board is there so that if we drop items or we kick items off of the floor with our feet, that they'll stay on the scaffold. They won't fall down below and hit someone that might be standing below our scaffold. So again, for our fall protection, we use a top rail, 42 inches, a mid rail, which is halfway between the surface we're standing on and our top rail, and then a toe board around the base of the scaffold that will keep anything from falling below. If we have material that is stacked above our toe board, then we would actually want to net or put some kind of screening in between the floor surface and the top rail to hold our material on the scaffold. Okay. The last thing I want to talk to you about, the last point I want to make today, is about our inspections. Every scaffold, OSHA says a scaffold should be inspected at the beginning of each shift by a trained, competent person. So we want to make sure that before each shift, that person not only inspects the scaffold, but signs off that we have and puts a green tag on a safe scaffold.
I really liked that segment. Next up will be ladder safety. I thank you for joining us. Ladies and gentlemen, Mr. Greg Stridd of Safety Training Exchange. We'll be back. Welcome back. Now we have Dennis Hollingsworth Jr. with us with Axis Remedial Sciences. Welcome back to the show, Dennis.
Thank you, Gordon.
I think this is now your third time on the show with us.
Yep.
And quite a regular. Recently, I had looked at some Consumer Product Safety Commission data, and it indicated a lot of people fall from ladders every year. Isn't that correct, Dennis?
Yes, it is, Gordon. Actually, the number is 90,000 people will fall and end up in the ER this year alone.
90,000 people
90,000.
in the emergency room this year. That is incredible. We have a select video clip of Dennis providing fall protection training in regards to ladders, and let's go to that now.
4 key reasons why people fall off ladders. Reason 1, wrong ladder selection. Reason 2, using worn or damaged ladders. Reason 3, incorrect use of ladders. And finally 4, incorrect ladder placement. Wrong ladder selection. On the side of each ladder, you will find the weight rating to tell you how much your ladder can handle. So please take into consideration your weight and the weight of your tools. Now, if you notice, our ladder here is a 16-foot ladder that can handle 225 pounds. Using worn or damaged ladders. Before using your ladder, please inspect your rungs, rails for dents, dings, dirt, missing rungs, and cracks. Incorrect use of ladders. You shouldn't use a step ladder like you would an extension ladder. If you look here, this is not the proper way to use a step ladder. Step ladder should be fully open and make sure that the locks are locked into place before each use. And incorrect ladder placement. Now your ladder must have a firm, level ground for this footing. If you notice in our picture right here. You must also extend your ladder 3 feet above your landing and tie it up, as shown here. And remember to always use a 4-to-1 ratio for a proper climbing angle. A good way to practice this method is to take both your feet at the bottom of the ladder, stick your arm out, and when your fingertips touch the rung, you're good to go. And remember, always maintain 3 points of contact. 1, 2, 3. Never lean outside your ladder to reach. Always get down and simply move it.
Outstanding. Ladies and gentlemen, Mr. Dennis Hollingsworth Jr. of Axis Remedial Sciences. Thank you for being with us.
Thanks for having me.
Okay, folks, that pretty much wraps it up for us here on the Safety View with your fall protection and prevention session of training. And we hope to see you again next time. Thank you.